Making sure everything is going. Okay, we're good. Brr, brr, brr. Okay. Okay, so the question on the screen. Density of a chi-square, ABR gaming, random variable chi sub k squared with k degrees of freedom. It's given by this bad boy. Jed, congrats on the first. For any fixed L greater than 0. Why is this L different than this L? Bloody L. Receding Ed Sheeran. Damn. I'm doing alright. How about you? We're going to show this integral. So why do we care about this integral? Oh, never mind, because there's rho. I don't know. Finding with your permutation combination? Ugh. Good luck with that. It's 1 plus little o of 1. As k goes to infinity. Really? That's what... Well, this is the area under chi-square. Well, chi-square with a... I don't know what that thing is doing in front. The word problems suck? They do. We don't have to question this problem too much, so we can just try to follow through the steps and see what happens. So consider this integral, which is this integral with rho. Why is this rho and not chi, by the way? I guess rho is the density of the random variable. Okay, that's that question answered. We're considering this integral, which is rho without the constants. Okay, yeah, sure. We are going to eventually send k to infinity, so I don't like forgetting about the constants completely, but... not have to worry about that yet, maybe. Spelled by my singularity at y equals 0, argue the lower bound of integration. Oh, geez. Okay. Well, let's start with the change of variables, shall we? K over 2 minus 1 e to the minus x over 2 dx. We're letting y equal x over k. So dy is 1 over k dx. 1 over k... Oh, hey. This 1 over k flips. Well, okay, no. Let's not get too fancy. The bounds are still 0 to infinity. This x over k becomes y. That x becomes y times k. ky. E to the minus, this x becomes ky times k dy. E to the... Hey, Kyo. So out front, we're going to have a k to the k over 2 minus 1 times k. So it's just k to the k over 2, which is a weird thing. But I'll allow it. I'm doing all right. How about you? This is a y to the l. That's a y to the k over 2 minus 1. So it'll be y to the l plus k over 2 minus 1. E to the minus k over 2y dy. So that means our h of y, looking at this thing here, is minus y over 2. Our g sub l of y is y to the l plus k over 2 minus 1. And I don't think we'll need it yet, but ck is k to the k over 2. Okay. So the only other part for step 1, g sub l of y may have a singularity at y equals 0. Because L is just an arbitrary positive real number. Working a 3D project for bit tonight because tomorrow will be all about practicing iterators and comparators. Ooh, good luck. I'm kind of weirded out that we have to be concerned that G may have a singularity at y equals 0. Because we're sending k to infinity. But I think what they probably want us to do is to think about the integral from 0 to epsilon and bound that in some way. Okay, and so this is why, well, we're concerned about the case where this exponent is negative. So we need to assume here that L plus k over 2 minus 1 is less than 0. Hey, Rex. In which case we can upper bound... We can take the upper bound of this thing as... Well, it's diverging. It's not bounded. That's the issue. You will see success ahead. More money is in prospect. Fair enough. Um, thank you, thank you. This is so when y is close to 0, this thing blows up. This thing just goes to 1. So how does this argument even work? Like, hmm. Is this like a Watson's lemma or some crap? Okay, so what does Watson's lemma tell me? Okay. So Watson's lemma tells me am I really gonna write this all out? Fuck it. T v of t dt is finite. Phi equal. This is the part of Watson's lemma that is really weird to me. T to the sigma g of t, where sigma is greater than -1. This condition is really weird to me. You look pretty. Is that a fortune or an opinion? You know, if it's like you will look pretty, that's at least saying something about the future. I skipped over another condition about g having infinitely many derivatives, but who cares about that? Not me. factorial gamma sigma plus n plus 1. Lowercase sigma is so hard. So is uppercase sigma for that matter. Okay, I want to see if I can apply this thing to this thing. Well, really that thing. Hey Rushback, it's going all right. How about you? Um Amon, I'm studying for a master's in applied math at the University of Washington. Can I tell you what I'm seeing on my screen? This is homework for my low PhD level math class that I'm in. This is like the hardest class that I've taken here. It's like I'm a master's student, but I chose to take like the core classes at the PhD level just because I'm a nerd. And so this is some pretty heavy, like, graduate level math, so... It's kind of like, do you know Taylor series? Like, basically the idea of the class is that, there's certain functions that are too weird to have a Taylor series that converges, but, you can take that divergent series and sometimes still do something with it and get an idea of how the function behaves even though it diverges. And so that's like basically what we've been learning about so far in this class. Yeah, it's like with like a Taylor series, you just like you as long as you include more terms, you always get a better approximation. With an asymptotic expansion, you keep the number of terms fixed and you just ask like, where does this work? Like for what x is. Oh yeah, it's definitely intimidating. It's not easy. I'm probably gonna have to go to office hours multiple times to get through this homework assignment. But before I, but like, if I'm gonna go to office hours, I need to come prepared with a question. So I need to at least like try to do these. Why is there an epsilon on the bottom of the integral? Uh, oh yeah, it's like that one right there. The reason for that is that this is just like a generic function right here. Or at least like that. Sorry, I'm not explaining this well. There's so many letters being thrown around here that I'm afraid this is like gonna be a little hard to follow. But basically, this is the integral that I'm trying to work with. Y to a power times e to a negative power. And the issue is that the power of this y could be negative. And so it's basically like e to the minus y over y. And so we're worrying about y equals 0. We want to just delete 0 just to be safe and replace it with some really small number epsilon. And we're trying to justify why that's okay to do without getting too much error. I'm on, I'm sorry if I'm saying that wrong. This is about it's about a function from statistics. The class is not about statistics, though. Yeah, basically, Rushback. Like we're trying to avoid issues just with dividing by 0. Basically, the point of this problem is to show that it's not going to matter much if we remove that, I guess. Yeah, I'm trying to work out how exactly we actually do that right now, because it seems like it matters for now, but apparently it shouldn't. This looks like a 9. Yeah, so we actually use Taylor's theorem a lot. Oh my god, it's been so long. Hard luck, thank you so much for that. I forgot I had that alert. Wasn't you? Yeah, my bad. I hope you're doing well, dude. Ugh, yeah, so we're using Taylor's theorem a lot to bound the error, like the one that's like r sub n of x is equal to f of psi something x to the n over n factorial. Oh, it's like the nth derivative, something like that. I don't know. I have it like slightly wrong there, but that's a frequent one to be used here. You know, I was exam 2 weeks ago. Oh, nice. Um, sorry, I'm still debating what to actually do with this. Error beyond all orders. Like, okay, if it when we get error beyond all orders, what is that supposed to look like again? Oh, am I doing this backwards? Should I be bounding the E? So this is exponential decay. Okay, wait. 0 to epsilon. Y to the L plus K over 2 minus 1. E to the minus K over 2y. dy. Less than or equal to 0 to epsilon. I mean, these are both positive numbers from over this range of y values, but who cares? K over 2 minus 1, e to the minus k over 2 y dy. So the exponential function takes on its maximum value at y equals 0. Well, yeah. No, I don't think that's what we want, though. I don't know. I don't think this is right. Clonk. Wait, this is a math one. What's yellow and equivalent to the axiom of choice? Zorn's lemon? Wait, there's a math fortune in there. What the hell? Is that actually true? I've heard of Zorn's lemon. I forget. What it says though. It is a wow. That's a math joke. I didn't even put that there. Like, I'm shocked that a random list of fortunes I got off Google has a math joke that deep in it. Holy crap. Hey Skirtle, carve your name on your heart and not on marble. That what? That just makes no sense. Don't sweat the petty things. And don't pet the sweaty things. George Carlin. That's good advice. You must have a heart first, you dumb fortune cookie. That's true. Yep. Oh, you're rebuilding your PC? Oh my god, no sound. Let me type to Clonk. Um, I'm still so surprised that there's a math fortune in there. It's not even a fortune. It's just it's a joke, but like, it's funny. And the bangers. Yeah, for today, this is a Coldplay song. Why does Spotify love Coldplay? Is Coldplay paying Spotify to insert them in more radio jams or something? Or radio stations or whatever? I put this on to just like whatever Spotify generates as the radio station for Feels Like Summer by Childish Gambino. And for whatever reason, they think that Coldplay should be in there. It's known to be shitty. I'm kind of shocked. Like I've never had a like that much luck with Spotify's algorithm, but I thought it was just me. Like the way I listen to music is kind of weird, where like I tend to just like turn on albums and just listen to albums like all the way through. And I feel like that messes up the algorithm because I don't actually like all of the music on the album, but yeah. YouTube music is the way. I have found a lot of good music through YouTube. It's fair. Huh. Maybe Dora, a 5-word summary. Um, okay. I can do this. Mm, okay, estimating integrals with few terms. There you go. Why use many word when few word do trick? Um, yeah, no, that's actually not a bad like summary for what's happening. The estimation has few terms. The integrals themselves are just like some weird thing that we don't know how to integrate directly. But using something called asymptotic analysis, you can get an idea of how the integral behaves at least. Um, and I'm currently looking through my notebook trying to figure out what the hell I'm supposed to do for this problem that's on the screen right now. Beyond all orders in K. I don't know. This uh this is like as it's still pretty applied. But like it is like a spectrum. So like okay. If this is the pure end of the spectrum and this is the applied end of the spectrum, I would put this class like right in the middle. And my other two classes are like pretty freaking applied. So like this is like a relatively more like theoretical class that than my other ones. It's still like if a pure mathematician was taking this class, they probably would be really mad at all the stuff that we're doing though still. So it's kind of like 50-50. Um, the thing I always get confused on with trying to do Watson's lemma is like this construction for phi of t. Uh, like if I have if my integral is 0 to epsilon t to the L plus k over 2 minus 1 e to the minus k over 2 y. Oh, t. Um, Wait. I don't know. Is this entire thing my sigma? Or I mean, like this entire, or yeah, this is my sigma? Or do I need to split it up and be like, actually, what if, can phi depend on lambda? Because that's what we have. There's a k here. Uh, I don't know. Do I have an example of where we've used Watson's lemma? Looking. Cooking. Good looking. Error that is beyond all orders in K. Beyond all orders in K. Or should I be integrating by parts? That's a thought. Beyond all, we are sending K to infinity. So I'm kind of confused why we need to even do this in the first place. Okay, maybe integration by parts is what we want. I'm not sure if Watson's lemma even applies here. U is equal to y to the L plus k over 2 minus 1. dv is e to the minus k over 2y dy. du is L plus k over 2 minus 1. Y to the L plus k over 2 minus 2 dy. V is equal to minus 2 over k. Oh my god. Terrible writing. E to the minus k over 2y. K to the k over 2. Minus 2 over k. Y to the L plus k over 2 minus 1. E to the minus k over 2y from 0 to epsilon. Well, fuck me. How are we supposed to do this? If we're worried about this exponent being negative, this thing just blows up. Like, hmm. Maybe, can I kind of cheese this? So I'm coming back around to the idea of Watson's lemma now. But maybe not exactly like that. So if we were to use an idea like Watson's lemma, I think what we would do over 2y is do a Taylor series for that thing. Do 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 do. Hmm. What song is this? Oh, okay, I've heard this. On Melancholy Hill, Gorillas. Uh, so wait, actually, oh, maybe something that's confusing me is I should maybe go back to the original integral and try the change of variables from there. Because that does change the upper bound. And that kind of matches what we did in the proof for Watson's lemma. So if x is 0, y is still 0. If x is epsilon, y is epsilon over k. Is that right? Should be fine. So we get y to the L, ky to the k over 2 minus 1, e to the minus ky over 2, k dy. K to the k over 2, terrible 2. Epsilon over k, y to the L plus k over 2 minus 1, e to the minus ky over 2 dy. Now, what was the point of doing this? Hey, Zach. Happy Tuesday. Hope you're doing well. Just working on this problem, doing an asymptotic expansion for... I don't quite know what this is supposed to be. Maybe this is this is some weird like moment of the chi-square variable. Maybe that's what this problem is supposed to be about. But yeah, I'm just like looking through my notebook trying to find a relevant problem that we've done and trying to follow that procedure. We were given a hint for one of these problems in a class yesterday. Actually, I think it was a different problem. I was on the homework, but we definitely got a hint of some kind. Where did I write it? No, I can't find it. Come on. No way it's this far back. I don't know. I can't find it now. I don't think it was for this problem, though. So, hey, Papadoria. The basics of cardinality of sets, like if you're talking about like Cantor's diagonalization, I know that. And that's of like the natural numbers, integers, rationals, like that kind of like hierarchy. Huh. So integration. I mean, okay, wait. Have I just been thinking about this wrong? As k goes to infinity, I feel like I'm maybe making this too hard on myself. K is going to infinity. We're integrating in y, but k is going to infinity. To the minus k over 2y dy. Okay, you're taking a p-adic analysis course, and as a precursor, they pose the following problem. Oh god. Let's see. P power set. What does it mean to square a set? Is that like a Cartesian product? Like R2? Okay. Um, yeah, hello, hello. Uh, there's no particular reason for this, but my gut is telling me no. I'm trying to figure out why I would feel that way, though. Maybe it's yes. I mean, I wonder if infinite sets, well, ooh. Oh. Wait. No, ooh. I don't know. Let's see. It's the power set of A squared. Yeah, the fact that they're power sets makes it harder for me to think about this. I try and think about this with. I mean, should we do like should we just check it for like a finite case? I assume the finite case is going to work, but if A is 1, 2, 3, 1, 2, 3. This is a little bit tedious, but I'm not that good with sets, so I need to 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 do this. The more I make them, the worse my curly braces get. Wait, how do you make the empty set is like that, I think? I don't remember. So that's 1, 2, 3, 4, 5, 6, 7, 8. So A squared is 1, 1. The more general question was, what is the relationship between the cardinality power set A times B? Hmm. So, yeah, that's weird. Okay, man, A squared is a lot of things to write out. Wait, I guess it's 9 things. Wait, if it's 9 things, this already isn't working then, right? Because 9 doesn't go into 64. Well, okay, what is the power set of A squared? That's kind of annoying. I mean, I feel like there should be a relationship between A and, like, can we say there's a relationship between A and P of A? Oh, let's see, Jed. Like, I feel like it should be, since elements in a set are distinct, I feel like you should only need to know how many there are. to know how many power sets, or to know the cardinality of the power set. What's the original question? Power set of a Cartesian product. Oh, this is basically the exact question, I think. Two to the A. I should have seen that one coming. Did I assume A and B are finite? It might. What is the power? I mean, are you doing the power set of an infinite set? Like, unless you're doing Aleph stuff, right? Like, or ordinal, whatever it's called, infinite ordinals. It will be hard to express the difference between the cardinality of R and the cardinality of the power set of R, right? After in general. Yes, it's that's the thing that I was wondering about the relationship between like A and P of A. This makes sense. So if we can establish these two things, I guess spoiler alert, Papadoria. Actually, well, you said, I don't know, if infinite sets are a concern, then this isn't a spoiler. But I guess we don't have to consider infinite sets if we have a finite set that's a counterexample. Unless like there's a stipulation on A that you didn't mention, I guess, but hey, okie dokie. Um, yeah, I think this is basically the answer here. So hey, thank you for finding that, Jed. Um, I don't know if I maybe would have eventually gotten here on my own, but I was getting a little confused with how to work out the power set of A squared. That's going to be a pretty big set too. What a generous endeavor. Hmm. Yeah, no worries. Thanks for the question. So bad with things like this is all you do is analysis. Yeah, this is like not my strong suit either. It's type of like discrete math stuff. P-adic analysis. I've heard of p-adic, the like stuff in general. I don't know what it actually means. Okay, so what is a p-adic number? Is this... What? Digits based on a prime number p rather than... So this is base... I... Okay, so it's a rational... Talking about numbers in a rational base. Maybe. Yeah, the Wikipedia page is... I really shouldn't go to Wikipedia page for an introduction to anything. So did my calculator not display in a fraction when solving 0.5 over 12? The power of 48 plus 1 minus 1 divided by 0.5. Not display in a fraction? Like, not display the result in a fraction? Or what do you mean? Hey, famished. How do I solve 3x squared minus x equals 8? The star consider the field extension by equating the roots of your polynomial to the base field. Say about the group of automorphisms that fix Q. Oh my god. This is real. This happens way too often on certain math like Discord servers or forums. Try to solve 0.5 over 12, but it just puts in a fraction. Don't neglect the fit level of these people. Yeah, that's true. Yeah, I'm not a fan of that either, Zach. Begonia? I never heard of that one. How do I learn math without eating my computer out of the window? That's a tough one. You just have to expect to, I swear, for personally, I never expect to get anything on the first try. It makes it a lot easier. So you're trying to solve 0.5 over 12, but it just puts in a fraction. I guess I'm confused, because if you're doing 0.5 over 12, don't you want a fraction? I'm sorry, I feel like I'm just not... It's gonna be hard to like express this in words, what you're asking. 0.5 over 12. Yeah, I'm not sure how to help you there. Okie dokie. Leon, yes, there's two resources that I can recommend to you. Let me open them up. 1 second. Okay. So depending on your level, OpenStax has books that are free and legal, and they tend to have like, I think they only go as far as calculus, but they go through like all like the basics of math. So algebra, trig, pre-calc. So if you're looking to like just get into the early parts of math, OpenStax is probably your best bet. If you want higher level math, this website has free and legal university level textbooks. They can just download right off here. Here, they don't have the greatest UI, but yeah. It's really cool that sometimes we can see that the 10 attic number 0.999 with 1 is never ending series of zeros. Math Pond, thank you so much for the raid. How was your stream? What were you up to? I hope your 24-hour stream went well. If you want to do the old raid and run, please do. Your mama was a snowblower. Welcome in. Thanks for the follow. No worries, Math Pond. We're talking about a few different things at once right here. Let me... Okie dokie is asking about just using a calculator. A is equal to 1,000. 1 plus 0.5 over 12 to the 48. It's quite an exponent. Minus 1 divided by 0.5 over 12. Try to solve the answer of the first half. I divide it by 0.12. 0.5 over 12, it comes out as a fraction. It's been a long time since I've had to use a calculator, to be honest. And back in my day, calculators just always give you a decimal. I think there's usually like a button that converts fractions to decimals, though, if that's what you want. I separate the 1,000 from both? Oh, okay. Maybe just like out in front like that. Computation extends the meaning of a function. P-adics show that 999 is an actual minus 1. Negative are built into p-adics. For prime p's, fractions and imaginary numbers are built in. That's kind of crazy, Papadoria. What kind of calculator is it? No worries, Leon. Sounds good, Papadoria. See you around. Basic scientific one. A Casio? Okay. Maybe you have buttons that look like this? I guess they have a little, like, fraction button there. Tip of the hat to the Ed Sheeran stunt double joke. Thank you, Snowblower. Yeah, well, when I first started streaming, I didn't have a face cam. I added the cam a few months after I started, and in the first stream I did, people told me that I looked like Ed Sheeran, so it's like, oh, it'd be fun if I put that tag on. S equals D button to change it. It matches album covers. I don't know what his album covers look like. Now I'm curious. I'm gonna. The ones I'm seeing are kind of abstract. Wait, Ed Sheeran? What is this album? One second. Just scrolling through his Spotify page. Ed Sheeran has an album that looks like this. It's math. Oops. That's what you're getting at? Oh, nice. Okay, so like you don't have a button that's like that. You see it? Does it do what you want if you press it? Oh, okay, yeah. So I guess maybe try it and report back. Hey, Mavort. Yeah, I have seen Zach working on that. I think he's working on like um maybe something that's a little more like introductory for differential equations. The class that I'm in is pretty deep in the weeds. Uh we haven't it's called Advanced Methods for ODEs. We're halfway through the class. I don't think we've actually solved a single ODE. It's just been laying the foundation for it. Um uh Oh, no, that doesn't. Oh, sorry. No, no, no. Oh, I don't know how to type. Oh, 416. Yes, I agree with that. Okie dokie. Um, but yeah, so far this class has been talking about like using asymptotic expansions to estimate integrals, and I imagine that's going to come in helpful for ODEs at some point. We haven't actually gone to that yet. Um, in general, I think making a differential equations like introduction will be really fun though. And I've sort of been doing that because like it's sort of half been doing it. Um I'm signed up for a seminar about pedagogy in applied math. And as part of that seminar, we've been kind of like half designing a course. And so the one that I chose to work on is like the introduction to differential equations class. So it was about like writing learning objectives, creating a mock final, creating a mock homework assignment. And I think now it's kind of like veering off into something else, but I think it'd be cool to make an introduction to differential equations that's not just like here's integrating factors, here's separable equations, here's exact equations, here's like it is good to know all those tools, but it misses like the bigger story with differential equations. Calculator sabotaging me. I'm sorry. Okie dokie. Hopefully, you're getting it to work better now. Yeah, like I haven't followed what you've been doing like that closely, but I imagine that you've been like taking a different approach. I imagine that so far we're just talking about like estimating integrals. We're actually working on an example from stats for a homework problem. I imagine that the integrals that we're going to eventually get approximations for are going to be the like from the inverse Laplace transform. We probably aren't going to cover existence and uniqueness. I don't imagine we will. It's possible, but I don't imagine it's going to be our focus. Yeah, like as far as like differential equations go, I think like it could like you could take a lot of lessons from just like modeling and talking about the intuition for differential equations. Still have a pretty like robust class. Math makes you want to cry at night. uh, I've been feeling that too, for what it's worth. It's math is a special way of just making people feel stupid, myself included. But you'll get through it, okie dokie. I'll get through my stuff, and it'll all work out eventually. Is there any math professor that doesn't go 9,000 miles an hour? Very few. I don't know. It's a challenge to like, I don't know, effectively teach. Well, yeah, that's what I was saying. We haven't even, the class is called Advanced Methods for ODEs. We haven't solved a single ODE yet. We're just learning the groundwork right now. And this particular example is from statistics, yeah. But the technique is going to be the same, and we're just learning the techniques right now. Oh, the thing that you posted? Yeah, I can get you an answer. Let me just... Okay. I think that matches what you wrote. Oh yeah, that is an extra parentheses. Very small number, which is to be expected. 1.35 times 10 to the minus 62. That's a hell of a rational number. How many digits is that? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 64. 64 digit number right there. But yeah, so if I would say it's 1.35 times 10 to the minus 62. Okay, so what was I doing with this? K, okay, so the thing I was trying to do with this is K is going to infinity. Oops. Y is just an integral from 0 to epsilon. What is the alphabet starts showing up in a math problem? That's when the computer goes out the window. That's fair. That that is where math like kind of like takes a turn. E showing up from just numbers is crazy. Oh, like 2.71 whatever. Yeah. Oh, sorry. Or you mean maybe when like the calculator says like 3E9 or something? E can mean a few things, I guess. Okay, yeah. Yeah, that's just how like they tend to write, or how computers tend to write scientific notation. Sorry if you already know this, but it's the same thing as like times 10 to the minus 62 is easier for a computer to do the E and then the number rather than doing like a superscript. I don't get this problem. If K is going to infinity, I don't get why we need to worry about a singularity. For success today, look first to yourself. Ooh, that's a good fortune. Okay, I honestly I feel a little bit stuck on this part of the question. I think I could skip forward to the next part though, and come back around to this part. I'm gonna skip. I'm gonna try to just go straight to step 2 because it doesn't directly rely on the first one. Epsilon to infinity. E to the KHY. Well, this is surely we're supposed to do it with the thing that I found in part 1. Like that thing. Surely. Math is hieroglyphics for me. Luckily, my field does not use much math. Oh, good. Yeah, I mean, uh, I like math, but I know it's not for everyone. So be able to just like get through what you need and then not have to worry about it again. Extreme cat boy. I'm doing all right. Just doing my cat boy stuff like usual. How about you? Okay, Laplace's method. Though a tutorial on linear second order ODE? I assume there's a typo in there. Okie dokie. No worries. Okie dokie. Hope you have a good day. I hope your calculator starts cooperating from now on. Oh, you taught a tutorial. Ooh, nice. How'd it go? Um, my calculator out of the window, things could go down. That's the first to go though. Fair enough. I think GPT and other AI agents are as good as traditional books are. No, not right now. I think eventually AI is gonna get really good and take over. In my opinion, in its current state though, you shouldn't trust AI to teach you anything new. You can use it to reinforce things that you're learning about right now, but like if you can't verify something it's saying for yourself, you shouldn't trust it, in my opinion. One day that'll probably change though. Abel's formula. I kind of remember that. I don't. Let me see what it looks like. Oh, is this like variation of parameters? Yeah, it is. Okay. Yeah, I spaced out when my professor was deriving this. I still don't know how you derive it. I just always look up what the formulas are. Had an image processing class that was out of my league. AI was running around chasing its tail. Yep. It's really good at making it seem like it's doing the right thing, though. Decent for code documentation. I guess the LLM part is not necessary. Searching. Oh, yeah. It can be nice, like, because it's sometimes hard to Google certain tech issues, and AI could do, like, a way better job at figuring out what you actually want. The one time I tried to get tech help from ChatGPT, though, just kind of ran me around in circles. It didn't actually suggest any steps that actually fixed it. Um, so we want asymptotic expansion as k goes to infinity. I hate this. Uh, um, the the thing that I hate is that in class we learned the setup for Laplace's method we learned was for an integral of form a to b g of t e to the lambda r of t dt as lambda goes to infinity. The thing is, so this is g of just t, but the thing I think is my g of t has a k inside of it, and k is my lambda. So, like, does it still apply? I don't know. I feel like it shouldn't, but apparently it does. Um, so with the plus method, the first thing we did was do a Taylor series of this minus y over 2, but that's just it's already its own Taylor series. Well, oh wait, a Taylor series about the maximum. Well, this is a linear function with a downward slope, so its maximum is going to be at epsilon. Well, yeah. A little bit with RAG, which is a word embedding system where you build a vector database where the vector represents some semantics of some string, meaning of the text content. The idea is that you have a function that takes strings of text and map it to a vector with close semantics. You can use that as fancy index system for documents. I don't know how a vector represents the semantics of some string. That's where I don't understand it. That sounds interesting. It's the word embedding part. I don't know what word embedding is either. So, okay, I think a maximum of h of y when y is between epsilon infinity. Well, is equal to minus epsilon over 2. Exactly turning string into vector in such a way that the string with closed meaning got mapped to two closed vectors with respect to some norm such distance. That sounds difficult to do. I don't know. I still feel like I don't get it, but I could see that being cool. I would search by semantics just like Google does. Okay. Um, I we seek there's supposed to be a change of variables that we can do here. I'm trying to figure out what it is. It's very smart. Control F. Okay. That does sound nice. Um, you know what? I can at least bring up the lecture notes. Maybe those will be more clear than my notes. Let me see if I can find the right set of notes. Not that set. Okay, this is it. The only problem is that people feed the output back to an LLM to generate a summary, which in my opinion is kind of dumb, as now it can hallucinate on your data. Hmm. Oh. You would prefer just having the word embedding result rather than the LM trying to give a shitty summary of it? Yeah, that's fair. So the thing I've been kind of debating is that in how we learned the Laplace's method, the function up in here has a Taylor series that we just take the first three terms of. The second term is 0. But a linear function um it doesn't have a Taylor series that it doesn't have its Taylor series does not go to degree 2. Oh. Uh Abuelas? I don't know what that means, but thank you for the prime. I appreciate it. I don't know why the alert isn't playing. Um I feel like that means something dirty and maybe funny. I kind of want to put into Google Translate. Cuz I know Abuelas is grandmas. uh, yeah, I can show this. Grandmother sucks scrotums. Thank you for the prime. I saw the word scrotos and I was like, oh, is that what I think that is? It turns out it is. Word embedding model are also quite lightweight, so you run them locally on your own hardware. Oh, okay. Wait. Oh. Yeah, our prime is not 0 for us either. Wait, we do have this like first case here, I guess, maybe. That means just if I'd be able to search the stack project, 7,500 page PDF. Oh my god. Yeah, I definitely don't want to do that by hand. Um, so we're gonna, I think my next step would be to define this r tilde function, but for me it would be okay, let's just for me it's this h function. So my h tilde would be minus y over 2 plus epsilon over 2. So when y equals epsilon, we get 0. And that's our maximum. We seek a function t of s such that r of t of s is negative s. And so for the sake of Laplace's method and just proving it in general, we use the implicit function theorem to prove that this change of variables exists. But I guess we can actually just find it, or at least we should be able to. So we want to... Yeah, I feel like you and I have talked about that. So maybe I was kind of overthinking how to actually do this, but maybe we just literally do this. Yeah, okay, that's when you said it's like the final boss of undergrad analysis. I can remember if it was implicit or inverse. So I guess we just solve this for t of s, and hopefully good things happen in life. They're equivalent? Oh. Can deduce one easily. What is the inverse function? Oh, it's just that the inverse function exists in... I guess that'll make sense. For a real function, f has a continuous derivative near a point where the derivative is non-zero. Near this point, f has an inverse function. Okay, that makes sense. Yeah. That they'd be equivalent. Okay, so we found our change of variables. What's all this? Far as I can t is analytic in S, taking S derivative of star. Oh, I mean, did we prove it? No, we did not prove the implicit function theorem, and thank God. This is applied math. We don't care about your stupid proofs. Keep them to yourself. Oh, really, Zach? This bit on Laplace's method has been like a week of lectures. It's a really big thing. Or it was a week of lectures. We've now been spending like a week on steepest descent. Doing stuff like, oh wait, that reminds me. Um, when we were learning about the method of steepest descent, my professor wrote the Cauchy-Riemann equations in a really cool way. If you have a complex function, I guess f of z is equal to, well, f of xy is equal to u of xy plus I v xy. The Cauchy-Riemann equations say ux equals vy, and that vx equals minus uy. Yeah. The d bar z. No, I think I've seen that. Maybe, I don't remember. What you do is you take the first equation, multiply it. Since these two things are equal, you can multiply this equation on one side by vx and on the other side, sorry. Ugh. Minus uy on this side, vx on that. Oh, that's not vx. That's vx on that side. So you get minus ux uy equals vy vx. Add the u's to the other side. Wait, no, I did this wrong. Ugh, I had it right the first the other time. Ugh. There we go. This is what I want. Ux vx minus uy vy. Add this to the other side. Ux vx plus uy vy equals 0. Well, this is two gradients dotted together. Gradient u dot gradient v. So the gradients are perpendicular. And I was like, oh, that's kind of neat. I never saw that before. But yeah, and that's an important fact because we've been learning about the method of steepest descent, where if you have an integral from like 0 to 1, for example, that's too difficult to compute directly, you can look at it in the complex plane and travel along level curves instead and get an equivalent contour that's like easier to like work with. Mutually orthogonal. Ooh. I told you that homomorphic functions are conformal transformation. Oh, preserving angle? Interesting. Actually, I think it's like this. So yeah, if you're trying to do an integral on the real line from 0 to 1, but that one is too difficult to do, method of steepest descent, I guess tells you that you can get something done by traveling along level curves in the complex plane. This is an example we did for a specific function, but as long as you don't like run through a singularity, at least you're fine. I'm doing a bad job of explaining this, but these are level curves. We're looking at it for f of t equals I t squared, where t is a complex number. And so you get these hyperbolas for level curves. But yeah, anyway, that's just a digression. Oh, and actually, I guess the important part of this thing is that you send like this off to infinity, and this little bit here goes to 0. You required orientation preserving properties for conformal transformation. You have holomorphic functions equal conformal transformation. Holomorphic functions are conformal transformations. If they preserve orientation. Huh. Weird, because I was thinking of how the Mobius transform has like the one point where it's not analytic, but that I don't know if that preserves orientation though. So can we just do the change of variables here? Holomorphic are always angle preserving. But yeah, I mean, I was saying the Mobius transform isn't. It has like the one point where it's not holomorphic. Because they look like they have like the singularity. Complex determinant formula in terms of the real determinant. That one I don't know. Oh yes, Snowblower. I've heard of that book. I haven't had a chance to read it though, but I really like the idea of it. Oh yeah, this was your first time here, isn't it? So I should introduce myself. I'm Don. I am a master's student. Going for a master's in applied math. Actually, I think as of this week, I'm halfway through. It's just a 1-year program. It's like the exact like halfway point of the program. And so we go by quarters here. Last quarter, I was in an applied complex analysis class, and I spent the the summer ahead of that studying for it because I was nervous about it. And I use a different I would have used visual complex analysis for that studying ahead, except I ended up finding out the textbook that the class is going to use and studying out of that instead, just because it felt more relevant. But if it wasn't for that, I would have rather used visual complex analysis. But yeah, and so that's Gordon. So now this quarter, the class that I'm doing this homework for right now is called Advanced Methods for ODEs. And so it hasn't. This is the first time we've really gone into complex analysis stuff or used anything from there, really. With the method of steepest descent stuff that I was talking about down there. Mobius transformations have a singularity as a map from the Riemann sphere to itself. Oh. Okay. We know the Riemann sphere is secretly S2. You can see the Mobius transform is just a rotation of the sphere. Is S2 just like... Is that just a sphere? A two-dimensional sphere? Okay, yeah. Yeah, I guess like a two-dimensional surface in 3D. Yeah, I'd love to give that book a read at some point, but that won't be for a while, unfortunately. Do you know the natural way to introduce Mobius transformations? I know of them as like a mapping from the complex plane to a sphere that either sits on top of it or halfway through it, depending on your preference. Is there a different way of introducing it? I was thinking it was a complex linear map on C2 to C2 that is invertible, right? Yeah, I remember last quarter there's a homework question where we had to solve a PDE on like a domain that looked like the intersection between two circles, or I guess not the intersection. Like you have one big circle, one small circle, and the domain we had to solve the PDE on was the area in between them. And we use a Mobius transform to like transform the circles into just an infinite strip. That was much easier to like work with. So I usually think of Mobius transform as related to some matrix. Hmm. Yeah, it does have like yeah, it does kind of look like a matrix, right? Your sphere also has another secret, namely CP1, the complex line in C2. Oh. Yeah, it's like the same thing, I guess, because they can be mapped to each other. What am I trying to do with this change of variables? We want r of t to become just minus s. So do we let what do I do with this thing that I found? Do I let minus y over 2 equal that? There's a map C2 without 0 to CP1. Where you just send a non-zero vector onto the line it generated. It's like a projection, is how I'm imagining it. It's kind of, this is like weird, like a 4-dimensional vector projected onto a 2D space, right? In complex line, complex linear subspace of dimension 1 and C2. Well, but it's a dimension 1 complex number still two-dimensional, like it's still a real number plus an imaginary number. That's maybe that's why I'm confused. Don't think of them as real vector space. Sure, what's the difference between C and CP? Now that I think about it. C is just regular old complex numbers. Or wait, CP1 is the complex line in C2. That's what you said before. Projective. Line is just a one-dimensional vector space in whatever field you want. CP1 is a set of lines pass through the origin in C2. Okay. I think that's a fancy way of saying the way that I originally learned about this mapping. If that's C, oop, I don't know how to draw circles. Like, is this, are you just talking about how like you can map the top of this, like, it's like, how mapping was explained to me is that you can draw a vector from the top of the sphere to anywhere on the plane, and that's how you basically like do this mapping. And I feel like this is, you're talking about the more rigorous explanation of that. Stereographic, oh, it's not? Okay. Welcome back, Math Pond. Hope the chickens are good. If you look at non-zero element of C2, you can look at it span, and this will give you a complex line. I don't, I think I'm a little lost then. Because like if you want to say that like um a complex number is one dimensional, I can believe that, but I'm having a hard time understanding what's happening. You can actually formulate special relativity that way? That's interesting. I've learned a little bit about special relativity. I'm not very good at it though. Pick a non-zero vector in R2. This will generate a line, right? Sure, yeah, like all the scalar multiples. So like 1, 2 generates a line with like slope 2 through the origin. Okay. And C2, like one element of C2 would be like 1 plus I and like 2 minus I or something. It's a very small C. Okay. And so the part where I'm confused, we're like, okay, this is technically two-dimensional, but really I would think of it as more like four-dimensional. Like, okay, this is at least a good like metaphor to like think of. Like, I probably just shouldn't try to visualize this. It is technically 4D? Okay. You have a non-zero element of C2, you can look at its span, and this will give you a complex line. Okay, yes, that makes more sense now. The map C2 without 0 to CP1. So we take a non-zero vector, associate it to the line it generated. Okay. Yeah, R4 is like isomorphic or whatever morphic to C2. Wait. Whatever morphic. Yeah, I've heard of like all the different like automorphism, diffeomorphism, homomorphism, isomorphism, like whatever. I don't know any of them. I've tried to study abstract algebra once and I didn't get very deep into it. It turns out that because invertibles uh complex matrix preserves such lines, map a line to another line. Yes, if it's invertible, it preserves lines. Like you can always like recover the original line, I guess. It's not like a projection where you just like lose information. Dude, I still don't know what to do with this change of variables. If A C2 to C2 is linear and invertible, we have an induced map on A star CP1 to CP1. Huh. Because A maps lines to lines. I guess so. Yeah. So A star, just do the obvious thing, given a line. It looks on what line A map to your given line. I think I kind of understand that. If I go back to thinking about R2, I guess. Oh yeah, I mean, the if I just wanted to like only do the problem and not talk to people, I probably just wouldn't stream this. But it's more just like I'm trying not to let there be like dead time on the stream. That's why I keep like looking back at the homework problem. But yeah, I mean the reason why I like doing this is to like talk with you all. Those A star CP1 to CP1 are exactly the Mobius transformation. Huh. Just need to take some coordinates on CP1 to recover the usual map we know. I mean, okay. Ooh. There are some issues. Like it doesn't just map lines to lines though. The Mobius transform. If a line goes through the singularity, it maps lines to circles. It only maps a line to a line if it doesn't go through the singularity. So you're thinking of the Mobius transformation on a given coordinate patch. Yeah. The circle is still... Oh, it's one of those things? Okay. Okay. On the other coordinate patch will just be a regular line. That's kind of annoying. But okay. I, I I guess what is a line if not a circle with infinite radius anyway? It's more of a coordinate issue rather than geometry. Okay. Not happy about it, but okay. Okay, that's I think the section I was looking for with this problem. I want to write this to look like that. So I need to do a plus and minus trick. I have an e to the minus epsilon over 2 out front. I can have an e to the plus epsilon over 2 inside here. They're a regular line in C2 without the funky stuff? Okay. So what am I think I'm letting y equal 2s plus epsilon. So dy is 2ds, Nintendo DS. If y is equal to epsilon, s is equal to 0. Y is infinity, s is infinity. Isn't this k messing everything up? I think I did it slightly wrong. It's a bit like the origin of R2. It's a very weird object if you think of it from a polar coordinate point of view. The origin is now a line in the theta r plane. The origin is a line. Line given by r equals 0 and theta can be whatever. That's still just a point, isn't it? If r equals 0? I know that theta can be whatever, and that's like a weird thing. Spicy ramen? Yeah. I uh I haven't gotten it in a while. But it's ramen you can get at the grocery store that I really like. This. I think I usually get like beef. I don't think it's that exact flavor, but it's this brand. It's really spicy, but it's really good. It's good for instant ramen, I should say. The line in the r theta plane. R equals 0 theta. If r equals 0, you're just still at the origin in the r theta plane, though. Line segment. But it's like a circle of radius 0, though. That's the one you're making? Oh, nice. I never ordered spicy ramen from a restaurant because I'm kind of like nervous. I probably should though. Like I bet they would make it like that spicy. Um. Oh. Oh my gosh. Oh wait, the change of variables is this equals minus s. Well, but there's the k. Should I have included the k? I don't know. Shug. I've been good. The answer is clearly Leggett Linnaeus. Equation is all wrong. It is. Have you been watching the show? The finale, is that today even? Today or tomorrow, I think? Made beef with rice, but you're still hungry? Ooh. That's my point in R2 with Cartesian coordinate. That's just a point. Polar coordinates see it as a line segment. Oh, okay. Yeah, I mean, I knew it was weird where like 0 isn't unique anymore. Because of that issue with like theta could be anything. But I didn't know that you would call it like a line segment, I guess. Um, you watched first, waiting a second to finish. Mm, I respect it. I've been. I mean, I missed out on the first few weeks, but I'm all caught up right now, and it's pretty good. Gotta say. Yeah, no, I won't say anything specific. I really want to because there were some things I was so excited for. I was literally like yelling at like, oh, there that thing is, but I'm not saying it. I know I'm not saying it. I'm not saying it. Hey Roxra. Oops. Um, am I getting? Should I have factored the K out or? Why can't I? If I want this to be a minus, why do I have to do this in the first place? Couldn't I have just taken y over 2 equal to s? You're always welcome to bust my balls, Shug. Thanks for saying hi. The USAD math test cooked me. Oh no. What is USAD? Like AD? I think of Arrested Development like the TV show, but it's not that. I'm not bad. Got a lot of stuff going on with school, but could be worse. Academic decathlon. Oh, I have not heard of that. That sounds hard. I wonder if I can find like the type of problems that they have. Um, Curriculum maybe? Algebra and trig, but what level? This is so fancy. I just want to see like a practice test. Oh, this is something that they're selling to you probably. Ugh. Okay, wait. What if I just say practice test? I just want to get an idea of like how crazy do they go. Um. Oh. I get maybe they don't publish stuff like that. What does this link have? Oh my god. Okay, well, I give up. Okay, no worries if you can't. I was just like curious. So when they say algebra and trig, I imagine it's actually going to be something a lot harder than just algebra and trig, or like like harder than you would learn in just like normal school. That's not right. L plus k over 2 minus 1 minus ks ds. Okay. And so allegedly we use Watson's lemma on this bad boy. Actually, let me bring up the next set of notes and see. Well, actually, I guess. Okay, this is the the notes just trail off here because that's where we ended for that day. But the next day, we just use the result of Watson's lemma. Theoretically, so we're trying to conclude it's this integral is 1 plus little o of 1 as k goes to infinity. And if you're little o of 1, it just means that you decay at all. So 2 to the L plus k over 2 minus 1. Watson's lemma. You give up? Okay, no worries. I gave up too. I imagine they're not like easy questions though. There's a good chance that I will get cooked too. Award ceremony to tomorrow. Hopefully you placed in science. Ooh, that'd be hype. I hope you did. Um, it was E and M this year, which you haven't learned yet, so it's pretty Ooh, that will be rough. E and M. I really love E and M, but it's a tricky one. That's a terrible sigma. It's a lot of unintuitive things to figure out in E and M. Gamma n plus 1 over k to the n plus 1. Well, this sucks. Like this k, I feel like this k shouldn't be here. We're sending k to infinity. I don't know. I feel very confused by this question. I feel like I haven't gotten that much accomplished here, but um, I don't really want to pull a marathon stream, and this feels like a decent time to call it, actually. So I think that might be what we do here. Yeah. So, fans here on YouTube, thanks for being here. I'm just gonna look for a raid.